Hi, geometry cherubs. In this area project, the next thing we're going to study is area addition postulate. Previously in the course, we've talked about the segment addition postulate, we've talked about angle addition postulate, and now we're going to talk about the area addition postulate, and it's analogous. So you use this postulate when you want to find this area of funky shapes that you can break into smaller parts that you can manage with one of the formulas we've studied so far. So if you look at this funky shape, you could think of this part of it as a square with 4 congruent sides and right angles. We see that's a square where all the sides are 6. And this is a triangle. But we'd need to know base and height. Well, we see this is the height, 8, but we need to use our logic to figure out what is the base, 6. So we could figure out the area of this triangle as well. And then we could add them together because the area addition postulate states that as long as there's no overlap or no gap between the two things, that the total area will be the sum of the two smaller areas. So the solution, the area of the triangle plus the area of the square will give us our total area. And when we plug in the numbers that we know, we get 60 square inches. So pause and just take a second and see if you can find the total area of this shape. And then pause the video and then press play for the solution. You'd use the fact that this, if this is 8 and this is 8 and these are all right angles, that this must also be a square that we're dealing with. And the minute we see that that side is 8 and the whole thing is 14, then we can easily calculate what this side length, this chunk is. Once we do that, we could break it into a square and a triangle using our knowledge of those formulas. So we could say the area of the square, 8 times 8, plus the area of the triangle, which would be half base times height. So pause, calculate the total area, and then press play for the solution. We would take the area of the parallelogram plus the area of the triangle. And the area of the parallelogram, in order to calculate that, you have to remember that in a parallelogram, opposite sides are congruent. So this base and the height that we're given would be comparable, would be connected. So the area is 15 times 21 for the parallelogram. But then how could you figure out the height of this shape? You'd have to use your knowledge that if this is 21, then the altitude here would also be 21 because this would form a rectangle. So the height here is also 21. Pause, calculate the total area, and then press play for the solution. So you could add this line here. And when you do, you'd have to figure out that if this is 40 and the whole thing's 120, then this is 80. And here, if you know the total, you know this is 60, what's left over for this side. Once you've done that subtraction, you can calculate the area of the rectangle plus the area of the triangle in blue. So practice and then press play. If you have any questions, then as always, just let me know. Okay, good luck, Walnuts.